Hello, thank you for watching. In this video, you'll learn how to identify extrema and categorize it as an absolute or relative max slash min. And you will also learn how to use that extrema to identify where a function is increasing and decreasing and how to express those situations using interval notation. So if we're going to first go over the extrema parts and identify critical points. First of all, critical point is just essentially again a point where the graph is going to change directions or concavity, which means its curvature. So if a graph is increasing, let's say, or increasing and then changes direction and decreases, then that's referred to as a critical point, like this one right here, where we have this maximum point there. That is a critical point. The point of inflection, where it's changed its concavity, its curvature, from concaving upwards to concaving downwards, as you see right here, this point of inflection is referred to as a critical point. And the minimum value, where it changes direction from decreasing to the increasing, it's also referred as a minimum point. So these 3 points right here in general are referred to as critical points. Now these two specific critical points are classified and referred to as extrema. Those are going to be points where the graph changes its direction. And the function changes its direction as a result of having a maximum or minimum value, whether it's relative or absolute, which we'll talk about in a second. Those are referred to as extrema. And like I mentioned, the point where the graph changes its shape and changes its concavity is going to be is referred to as the point of inflection. Now we're going to be focusing on the extrema today and how we use these critical points to identify where the graph is increasing or decreasing. So let's talk about those critical points there. Now these two critical points can be categorized as being the absolute highest or relative highest, and the same thing in the other direction, the absolute minimum or the relative minimum. So let's compare the words relative and absolute. The word absolute means exactly what you think, that it's going to be, in fact, in this case, largest. So if I say the absolute maximum, I'm referring to a point on the graph that is higher than any other point on the graph. The word relative is referring to the points close to it. So relative to the points near this green point right there, that green point that I've circled, that green point there is the highest point relative to all the other points within that area. Let's compare this one and analyze. Compare this to, let's say we have a 6'4" student in the class. The 6'4" student might be the tallest person in the class. Let's say he is. So the 6'4" student is the tallest person in the class. Okay, so that would be a relatively tall person, because compared to everyone else in the class, no one is taller. But if we're to find all the tall people and expand our search to not just the school but everyone in the world, I'm sure that he will not be the tallest. I'm pretty sure there has to be someone who is taller than 6'4". So that tallest person in the world would be the absolute tallest person in the world. But when we shrink the sample size and shrink again and only look in the immediate area of our classroom, he is relatively taller than everyone else. So that's the difference between those two things. And it's easy to see among a graph. So while this is a maximum and this is a maximum, this right here is referred to a relative maximum because it's the highest point among among this section or area of values there, while this one will be the tallest among all of the values on all of the coordinates on the graph. And the same thing is true if we're going to compare the absolute and relative minimum. It's just in the opposite direction. So as you can see, this is the absolute minimum, the lowest point on the overall graph. And this point right here is a relative minimum, because compared to the points around this blue point right there in this general area, this would be the lowest point, that turning point right there. So we have a minimum in both locations, but they're classified as different type of minimums, a relative compared to an absolute. So let's look at some examples. The famous quadratic formula or parabola. So as you see in this graph right here, we do have a critical point there because the graph changes direction, and that critical point there is classified as an absolute minimum because there is no other minimum point lower than that. Now this graph does not have a maximum at all, whether relative or absolute, because the arrows indicating that the graph continues increasing. So whatever point you find to be the highest, there's always going to be a point that's even higher than that, and a point even higher than that. So there is no absolute maximum or a relative maximum. There is no maximum at all. Just this minimum value there. Now remember, in order to have the maximum minimums, there has to be a change in the direction. The graph has to change direction, so we have to have a critical point. And in this situation, we only have this one critical point because from left to right, the graph is decreasing and then increasing. So there's this only one critical point there. Let's look at a graph that changes direction several times, like in this example here. In this example, we have a total of 3 critical points. We have this critical point here, here, and here. There's some other critical points there, like the point of inflection, but we're not going to focus on that. We're only going to focus on the max and minimum critical points, the extremas. So these 3 extrema here is 1 maximum and 2 minimums. Let's do this maximum in red and do this minimum in green. So the blue minimum that we have down here, this is an absolute minimum value because it is the lowest point among the entire graph. The one in red is only a relative max because there's points that are still higher than that. As you see, these points there, or even these points right here, they're higher than this y value for that point, but compared to the points around that red dot, it is the highest point in that section, so it's a relative max. And the same thing is true about this green point right there. So compared to the points around in this section that I've circled, that green dot there is the lowest. So this is a relative. I misspelled relative over here. Max and a relative min. Now, one of the reasons it's important to be able to identify these extrema is because we use these extremas to determine where our graph is increasing or decreasing. So for example, look at the graph we have here on the right. Notice that our graph is changing direction in 2 locations. So we have 2 critical points. This one right here in blue, that is occurring at x is equal to -1. And this point right here in red, that is occurring at x is equal to 4. Well, using those critical points, we can break our interval, which is the x values, only the x values that I'm interested in, from -infinity to +infinity into 3 sections. From -infinity to -1, from -1 to +4, and from 4 to infinity. And in those sections, because the graph is changing direction, it's changing from moving up to constant to moving down from left to right. So in this section here, to the left of -1, from left to right, the graph is moving in an upward direction. Again, don't worry about the arrow pointing down. This is just the way it's behaving on the left end. But from left to right, the graph has an upward direction. From left to right, in between -1 and 4, the graph is horizontal, so it does not move up or down. So it's constant. And from 4 to infinity, the graph is moving downwards, again from left to right. So we clearly see we can use that to then identify the intervals and create the intervals where the function is changing directions. So it's increasing from -infinity to -1. Now we use an open interval to represent all these x values. So from the x value of -infinity to the x value of -1, the graph is moving up. And we use, like I said, an open interval because at this point right here where the graph is changing direction, it is neither moving up nor down nor horizontal. It is changing directions. Think about it this way. If you're driving a car and you have it on drive moving forward, in order to put it on reverse, change directions, you have to put the car in a complete stop in order to shift it again from drive to reverse. Now, of course, some of you might argue, well, if you're a stunt driver, I'm pretty sure you can change that and do that move from drive to reverse a lot quicker. But yes, but even then, the car, regardless of how fast you do it, has to stop for one moment in time in order to change direction. So even in those situations, the car is in fact stopping in order to change directions. It has to. It is physically impossible to be moving forward and backwards at the same time. So even though you do it really fast, like I said, it has to stop in order to move back. So that's why we use open intervals at both ends, because at those two ends, it's not moving up nor down or horizontal. It is again changing direction. So it's stopping at that small moment of time. Well, moving on, like I said, in between -1 and +4, in this section right there, the graph is horizontal, so it's not moving up or down, it's constant. So we say that the graph is constant in the interval of -1 to 4. And then the graph is decreasing in the last interval from 4 to infinity. So let's look at a couple more examples. Now, the way that we break up the graph from -infinity to +infinity and create these intervals is that we start by first identifying all of the critical points, specifically the extrema. Point of inflections, again, are critical points, but I should be focusing only on the extremas, which are at these three places there. So this extrema is located at this vertical line where x is -3. This extrema down here in blue, also in blue, that is occurring where x is equal to 1. And this last extrema occurs at the vertical line where x is 4. So we're going to break our interval from -infinity to +infinity into 1, 2, 3, 4 sections. And all we have to do again is just simply look at how the graph is behaving from left to right in each one of those sections. So from left to right, the graph starts by increasing, then decreases, changes direction and increases, and then changes direction and decreases. So our graph is increasing from -infinity to -3, and which we use this symbol right there to represent that, +1, that's a +1, to +4. So the graph increases for all x values between -infinity and -3, and between all x values of 1 and 4. Our graph decreases for all x values between -3 and +1, and all x values 4 to infinity, greater than 4. So these are the two places where the graph will decrease. And again, we use this notation right there, union, which is again and, to represent where the two graphs are decreasing. So if there's multiple intervals where the graph is moving up or down, you have to join them again using our union symbol or and symbol right there, which is just a big old U. Let's look at another example. So in this example right here, we have two critical points, and we have a kind of a point of inflection right there. But again, we're only going to really be focusing only on the critical points, on the extrema, because this is also a critical point there, right? You see how the curvature changed from concaving down to concaving up at that point there. But we're only going to be focusing on the extremas, which occurs at this vertical line of x is equal to 1, and at this vertical line of x is equal to 3. So from negative infinity to positive infinity, we can break our interval into 1, 2, and 3 sections. Just like the previous example, from left to right, the graph starts off by increasing. It reaches this critical point, this extrema here, and changes direction and then decreases. It then reaches the last extrema down here and changes direction and then increases. So our graph is increasing from negative infinity to positive 1 and from 3 to infinity. And it decreases in between those two intervals, which is between 1 and 3. So there you go. Now again, thank you for watching. If you do have any questions, again, please don't hesitate to email me or message me on Remind. And again, thank you for watching, and I hope you have a wonderful day.